when you develop the device. And new when you like a new day, new vulnerability, new days, new vulnerability. So if suppose if the vulnerability is coming, any hack is coming, any patch is coming in your device, you have to update your device, you have to update the firmware of your device. So as of now we don't have the proper updation mechanism. How we will update our device? Like usually we use the OTA based mechanism open to update the IoT device. So usually what happen, we have a lot of laziness in, like we don't try to update the device. So the updation is the very big problem. So the this fix happen 4,65,000 pacemaker vulnerable to hacking and need a firmware fix. So this pacemaker's device got hacked. This hack come in 2016. And also use of insecure and or outdated components. So it means you are using the insecure libraries when you are developing the device, and you are using the third parties library. So it means that is basically you are going to give the one more open access to the attacker. And the next come as a insufficient privacy protection. So if I talking about the insufficient privacy protection, you have to your device and ecosystem must be secure, and without the basically it must be proper authenticate. If the user don't have the proper authentication, so any attacker can attack your device. And as well as insecure data transfer and storage. The problem is that the IoT device is too sensitive, and the making the encryption mechanism in IoT device is too difficult. So that's why what happens when we transfer our data from one point to another point, we send into the clear text. That is the basic problem. So we send into the clear text. When we are sending the data from one point to another point, so usually what the attacker do, it try to perform the man in middle attack and try to decrypt the data. And the another case comes as the insecure default settings. When we ship our device, we usually use the default settings like admin, and we don't give the permission to the particular user to change your default settings, default configuration. That is also the big issue in IoT device. See, we can connect any device to the any physical object to the internet, but also we have to concern about the customer as a user privacy as well. As it's not like we are developing the major problem is coming in the IoT. We are just developing the devices blindly. We are not going to focus on the user and customer privacy. Privacy is the very big concern. And the another thing comes as a lack of device management. Do you know today in IT world we don't know 25% for tracking the assets of our company or organization, we still use the Excel sheet, and we are not updating our Excel sheet. And 56% verify asset location only once in a year, and 10 to 15% user basically every 5 years. If we have the devices, we don't know how much devices we have. So still that is going to basically give the one more open point to the attacker. And the next scenario comes as a lack of physical hardening. Like when we design our hardware of the particular device, we usually mention the ports this is the port for the UART communication, and this is the port for the JATA communication, and this is the port for the SPI communication. We are not doing the physical hardening. When we are not doing the physical hardening, it means the if we are going to give the access to the attacker, it can perform the attacker can do the reverse engineering. And once the attacker can do the reverse engineering, it can try to extract the firmware from the device. That is the basic risk and challenges in the IoT device. So once we have the risk and challenges IoT device, now the next scenario comes as that we have to solve that risk as well as we have to perform the pen testing. And when we are doing the pen testing the IoT device, we know how we can sort out that issue. So penetration testing is a type of security testing that is used to test the insecurity of an application. When we will perform the penetration testing of any IoT device, we will get to know how much big bugs our device having, and what are the layers, and that can be the like what are the attack surface. So in which basically domain our devices can be hacked. So it is basically conducted to find the security risk which might be present in the system. So basically we are performing the security assessment. Penetration testing, you can say we are doing the security assessment, and to prevent to reduce the risk of that particular device. So before doing the penetration testing, there is a particular step which we have to follow, like a planning and preparation. First we have to do the proper planning, like how we will perform the attack on that particular device. And after that, the second thing comes as a reconsistency. So it means we should have the proper knowledge about that device, like what are the layers about the device, what are the attack surface map on that particular device. And once we have the all the knowledge on the device, and after that we have to do the discovery in the sense like what are the attack area on that particular device. Once we know the attack area of that particular device, after that we have to find the analyze information analysis, and what is the level of risk. Like once we perform the assessment on that particular device, and what is the level of risk on that device. So once we know the risk of the particular, like high, medium, low, that is define the risk, and active intuition attempts, and after that the final analysis, and after that the report preparation. So once we prepare the report after performing all the seven steps while we are doing the penetration testing, and we have to send back the report to the client so that the client can basically solve out all these bugs and issues. So now the thing is basically what are the like a discovery, and what are the basically the pen testing, what are the basically the attack surface vector on that particular IoT device. It can be hardware of that particular device, it can be the some firmware, it can be the network, it can be the wireless communication, it can be mobile web application, and it can be the cloud APIs as well as. So these are the six layers where we can perform the pen testing of that particular device. So when we talk about the hardware, and how we can now the question is that how we can exploit the hardware layer of the particular IoT device. So now if I want to exploit the hardware layer of the my IoT device, first step is comes as a consistent. So for this I have to know the full idea about my device. So there is a usually on the hardware we get to know the FCC ID. So it's usually mentioned on the device. You open the device, use the screwdriver, maybe you use the IoT beam workstation, and apply heat to device. Once you open the device, after that the third step comes as the exploitation. To exploit your device. For doing the exploitation, you have to identify the different chips and part number of the device. And once you know about the chips and part number of that device, after have to go to the to search the data sheet of the device and to find the more information pin out of the device. And the second thing, you have to do the UART port would be there, like on the on the image you can see the UART port, SPI port, JTAG port, some maybe some unfamiliar port protocol can be there, and as well as the external interface like USB. So basically these are the five communication port. Through that communication port you can try to get the data from your hardware, from your device, from your chip. So these are the five main protocol it is used while we do the communication with the device. And once you are able to do the communicate with the device, like you are able to access the shell of that particular device, after it you have to perform the backdooring. So performing the backdooring is upload malicious firmware and add your own component. So what you can do, you just extract the firmware using the SPI communication. Once you extract the firmware of the device, and after that you add some components on the firmware image, and after that again you can compile the firmware from the device. So it's you can open the backdooring or backdoor of the device as well as. So now the second thing comes as a firmware, and the if now you have to exploit the firmware layer. Now on the hardware, once you are able to extract the firmware image, so now you have to perform the firmware exploitation. For the firmware exploitation, there is firmware can be encrypted, it can be non-encrypted, and obtaining the firmware. So there are three ways. So first thing is obtaining what are the ways to obtain the firmware. So you can get the firmware from the vendor website, as well as you can sniff the firmware while while the customer while a vendor is performing like a OTA based mechanism. You can basically sniff the firmware. You can do the mobile reversing mobile application as well as, and you can dump from the device as well as. So there are the four ways where from that ways you can basically obtain the firmware. And now suppose you obtain the firmware. Now once you obtain the firmware, now the firmware is encrypted. like a web application is like a is not like if you are a IoT penetration testing, you must also have the knowledge of all this area. You must have the knowledge of the cloud, you must have the knowledge of network, you must have the knowledge of firmware. IoT is like a combination of all this area. So it's not IoT is a new, but it's combination of the all this area. And you must have the knowledge of network as well, as because the IoT device is basically connected to the network, and you have to, and maybe you can get the, you have to do the network. You must have the knowledge of the network penetration testing as well, as you can try to perform the brute force attack. You can see the some outdated some services. You can see either some port is open or not, and through that port you can basically, if suppose the when you are doing the nmap of the particular IP address, and you get to know like SSH is open. So once the SSH is open, you can basically directly connect to the shell of that particular device. So like you must have the knowledge of all these area. And then maybe some unfamiliar, if when you will perform the network penetration test, you will get to know some ports are open. And there is a something some radio communication, some radio hacking as well. As see, your device is communicating from one point to another point. So like some communication is like is also there, some radio based communication, BLE based communication, and as well as the Zigbee based communication. These are the basically part nowadays used for communicating the devices. And like for the radio, basically you can, there is a one device called as a HackRF. So HackRF is a device basically through that you can perform the replay based attack. So like as I mentioned, on the IoT device we basically send the data from one point to another point into the clear text. So basically through the HackRF you can capture the data, and after that you can try to you can try to basically, if the data is the clear text, it's okay. If it's not in clear text, you can use some tools and try to decrypt that data as well as, and as well as you can capture the data being transmitted at that frequency. Like HRF can work up to the 5 gigahertz. So like you can capture the data up to 5 gigahertz frequency. And like next the thing comes as a BLE. So usually on the IoT device we mostly use the BLE. There are two types of there are two types of things here. Like one is called as a Bluetooth and the other is called as a BLE. So for the Bluetooth So thank you everyone, and thank you Red Team for giving me this platform to share my views in the area of IoT, and wish you all the very best. Thank you. I got some question. Please explain Zigbee. So basically, Zigbee is like a device. So you can perform the communication up to 2.4 gigahertz, and Zigbee is basically used on the mesh-based protocol. So it can work it's like a one master, and it can be like a multiple slave. So it's not like a Zigbee is like a, you can say, router. You have the one router in your house, and the mobile can be the like multiple devices are connected to your router. So Zigbee work also like that. And the second question comes as a what knowledge of embedded coding is required. So basically in the IoT we usually use the embedded C coding to basically write the program to write the program of that device, and that is basically used to basic C program. And so if you are developing the device for this, you have to require the embedded coding. And if you are doing the penetration testing of the device, you should have the knowledge of like how you can perform the reverse engineering. So any source from embedded can be learned. Yeah, you can do the Google, and you can get to know more. And there are a lot of, basically focus on the embedded C, and the embedded C is like a lot of opportunities, and lot of coding sites as well. So for going to the embedded C, you must have the knowledge of C language first. If you have the knowledge of C, and then you can move to, then you can write the in the from the Red Academy. So for that you will get to know about the Bluetooth hacking, and you will get to know about the Bluetooth hacking, firmware hacking, and I have designed that course from the basic. So you can choose that course from the Red Team Hacker Academy. That is really very nice course which I have designed. So it's well very interesting, and a lot of application also there. Have any other question?